we are discussing about Rutherford's experiment, that is gold foil experiment or alpha particle scattering experiment. Just I will go through schematic, not actual diagram. Actual diagram is something different. But schematically, Rutherford took a gold foil. Gold foil was, according to him, it was very, very thin gold foil. So thin that hardly 4 atoms in thickness, like that gold foil, was taken by Rutherford. Now this is photographic film or photographic plate. This was something drawn like this, and alpha particles are bombarded over this. Now at that time much things were not aware about alpha particle. Alpha particle is essentially positive charge particle. Approximate at that time they considered +2 is charge on alpha particles, and then these alpha particles are bombarded over thin gold foil. What was the expected thing? That gold foil should stop alpha particles. But what result he obtained? They are strange result. Say maximum alpha particles traveled in straight line direction, but few alpha particles got deflected by angle of 30 degree, 60 degree, 90 degree, and so on. So like that alpha particles deflected also. Very, very few, that means 1 out of million, that get deflected by angle of 180 degree also. I don't know how they calculated, but they say that out of 1 million get deflected by 180 degree. On this data, that means actually it was expected that it would stop, but no, they get deflected by various angles and maximum traveled in straight line. On basis of this data, Rutherford says atom is essentially a hollow part. There are 2 types of space. There should be space between the atoms. He called that as interatomic space. As well as space is there within the atom also. When atom is hollow, then where is the mass of that atom? All mass is concentrated at the center, according to him, because alpha particles are heavy particles. It travels with very high speed, say 3000 km per second. Unaccelerated alpha particle that is having speed somewhere around 3000 km per second to 30,000 km per second. Such a high speed alpha particles are there, but yet no holes are formed here. That means atoms are not displaced. So atoms entire mass should be focused in smaller area, smaller region, that is he called as nucleus. He even measured the size of nucleus. He says that it is 1 lakh times smaller than atomic size. Now, what is the thing? It is essentially made up of positive charge. All positive charge is focused in nucleus. Therefore, he says that if radiations are going like this, they get deflected. Okay? If it is going still closer, it gets deflected with larger angle. And exactly head-on collision, then only back 180 degree. And this way he concluded the thing. Now where is the electron? He says electrons are extranuclear electron. Extranuclear means away from nucleus. So they are away from nucleus and they are revolving around nucleus, like planets are revolving around sun. So that's why this model is called as solar system model of atom, where now sun is at center, here nucleus is at center, here planets are revolving, here electrons are revolving around it. But in case of solar system, the force of attraction is gravitational force. What is the force of attraction here in case of atom? He says electrical force of attraction, positive negative attraction is there. Because of that, electrons are revolving around nucleus, and this way model was put forward. No doubt various doubts are here. First doubt, obviously this model is not able to explain spectra. Second, electrons are revolving around nucleus. Nucleus possesses all positive charge, but now Goldstein says that there is presence of proton. If all protons are there together inside nucleus, then why nucleus is breaking out? It should break out. It should split because positive repulsion is there. How nucleus is stable then? Various doubts are there. Then, according to wave mechanics, they say that if charged body is in motion, it should follow, it should emit continuous spectra. It should emit energy continuously and fall down inside nucleus. For that purpose, time required is 10 raised to minus 8 seconds. Keep in mind, this is ultra high-fi minute time. Within 10 raised to minus 8 seconds, all electrons should fall in the nucleus and there should be atomic catastrophe. Touchwood, this is not happening. Why? That means there are some errors in the model and we have to rectify it. Okay. Now let us discuss about the rectification. But prior to that, I must explain, because you might have heard again and again word that J.J. Thomson's atomic model is there, not able to explain spectra. Then we discuss Rutherford's model, not able to explain spectra. So what is the meaning of spectra? We are going to explain. Now we are discussing what is the nature of light. Because in order to get knowledge about spectra, we have to discuss this part. So first part here, that is, we can say what is nature of light. It is not 100% yet determined. Different theories are there. First theory, that is Newton's corpuscular theory of light or radiation, and second, wave theory of light. So right now we are considering wave theory of light as our basis. They say that light is in form of wave, radiation is in form of wave. Now once I am saying that there is a wave, certain characteristics of these waves we have to consider. So we are first discussing the characteristics of waves. You can see this way, this is positive side, this is negative side, this is the wave. Let us give similar example. If there is a stagnant water, pool of stagnant water, and we are dropping a stone in that water, so you will get concentric rings coming out from that. Concentric rings means having same center, rings will come out, that is called as waves. Then they will go towards periphery, again they will come towards center, like that situation is there. Now add some lighter material on it, say for example piece of thermocol, or say for example a balloon, like that, and then again drop that same stone. You will find that whatever the thermocol piece, that is not going towards periphery and coming towards the center. You will find wave is going towards periphery and coming towards center, but piece of thermocol will oscillate at its original position only. It will move up and down like that. You might have taken same experience, particularly when boat or launch that is there at you can say that jetty or something like that, and then you can check that every time that wave is coming, that ship is oscillating ups and down. It is not going towards periphery and coming back. It is just oscillating at that particular place. Now here you can check this way, that this is the direction of propagation of wave. That means this is center of pull, this is periphery. Wave is going this way, but particles will oscillate in this is the direction. They will oscillate perpendicular to the direction of propagation of wave. Propagation means in which direction wave is going on. So here the angle is of 90 degree, therefore I am calling it is perpendicular. So this type of waves, they are called as transverse waves. So light radiation, that is a form of transverse waves. So here we are getting these waves as transverse waves, where particles will oscillate in this direction. Now here, this is the maximum displacement. Now we are making here a line. This is called as mean position. So original water level was this. After creation of wave, we are getting something upward. This is called as crest. Whereas something going downward, we are calling this as trough. So one crest and one trough will account one wave. So single part of wave is something we have to consider entire crest, entire trough. Maximum displacement, this is the mean position. Maximum displacement from mean position, I can see this is as maximum. Therefore, I am the terminology is that this is minima. But this distance, that is called as amplitude. Amplitude of wave means what? Till what extent wave can go to higher height and lower height, that is the same. So this is called as amplitude. Now wavelength. Now this is one wave I have drawn, but maybe possible I may draw this is the wave like that. So how to calculate, how to determine wavelength? Here this is called as mean position. This is also mean position. Mean position. So one wave, consider one crest, one trough. Therefore, distance between alternate mean position, I am saying again, first we have to omit this and second. So distance between alternate mean position is called as wavelength. So first we are determining here wavelength, distance between alternate mean position. Now when we discuss this topic in physics, we are going to discuss somewhat more detail about this, because only this is not the definition. Several other definitions are also there. But right now we can consider distance between alternate mean position, that is wavelength. So wavelength is denoted by a letter. This is called as lambda. Inverted y like something. So this is called as lambda. This is wavelength. Now speed of light, we are denoting by letter c. That is speed of light, which is 3 lakh kilometers per second approximately. Real answer something 2.99 etc. But right now we are considering as 3 lakh kilometers per second, that is speed of light. Now frequency, you are aware of wavelength. Another characteristic of this wave, that is called as frequency. Frequency is now this is one wave, or rather I should say one cycle. So number of cycles passing in a second from particular point, they are called as frequency. You are aware of train. Suppose I am standing on the railway station and I want to go to X direction. I will ask what is the frequency of train. It can be given like that. Per hour 20 trains are there. So I will say 20 trains per hour. Maybe possible 1 train per hour. Yes, that is also frequency. Per unit time, how many trains are there? If I want to go by that through trains are there, long distance train, then it may be there like that 1 train per day. So unit is changed from hour to day. Certain long distance trains, they are twice in a week. So I have to say 2 trains per week. So like that frequency. So here cycle per second. How many cycles per second? 1 cycle per second, that is called as hertz. Because the person worked on this is having name as hertz. So 1 cycle per second is called as hertz. So 1 hertz means 1 cycle per second. So frequency is denoted by letter. This is something called as nu. So now we have frequency that is determined by letter nu. So you are aware wavelength is there. Now here obvious thing is there. I am drawing another wave. If light is there, that means speed is constant. of that light. At that time, suppose I am saying this is another wave. Like that. Now, here what is increased? Wavelength. So, in a second, suppose here two waves are passing. Red one, two waves are passing, but blue one will pass only one wave. Here we will get wavelength is more. Here wavelength is less. So in case of blue wave, you will find that wavelength is more. In case of this red color mentioned, wavelength is less. Wavelength is less, frequency is more. Wavelength is more, frequency is less. And therefore, we can connect this way that frequency is inversely proportional to wavelength. Wavelength is less means frequency is more. But I have always problem with this type of sign. This is the sign of proportionality. And I want to remove it. How we can remove sign of proportionality? So keep in mind always, when we are removing sign of proportionality, we have to put some constant over there. So, nu, here I will put sign and put some constant over here, lambda. So, actual thing is that I have to apply this way. This is 1 by lambda and multiply by some constant, equality sign and constant, that is substituting out this. So, this way we are getting substitution of constant over here. So, in short, I am writing this way that nu, that is equal to some constant into lambda. Now, same way, energy is there. Every radiation is associated with energy. I hope you are aware of microwave oven. A klystron tube is there in the microwave oven that is producing out strong microwave radiations. Microwaves, they are produced and absorbed by water molecule. That's why if aqueous substance is kept in microwave oven, then it is going to get hot quickly. But if water is not there, it will not get heated. Say for example, if you are placing a paper dish and potato on that and keeping in microwave oven, you will find potato is getting hot but paper dish will not. If you are keeping something in glass, then also you will experience same thing, that glass vessel will not remain hot or become hot. But whatever inside material is there, say for example potato or something like that, it is getting heated. So this is something we are talking about, microwave. So here microwave, they are having energy. Sunlight, you are observed, tremendous energy is there. So formula is that energy of radiation is directly proportional to frequency of that radiation. Now you are aware of frequency. So energy equal to, now I have to remove this equality sign and put here some constant. So again I will put some constant and write down this way, energy equal to constant into nu. Now everywhere these constants we are using, and then again and again we using k as constant. Instead of that, some specific constants are there. Let us discuss about these constants. So nu is equal to what we discussed, k by lambda. But you can check out, we here this relation is true only and only if speed of light is constant. Then only this relation is true. Therefore, we are considering speed of light here as constant. We are aware speed of light is denoted by letter c. So right now I am changing out this k now by c. So nu is equal to c by lambda. Whereas here E is equal to, now this k is replaced by letter h. Theory was put forward by a German scientist named as Max Planck. According to him, light is no doubt in wave but not in continuous form. It is in form of bundles. He said that bundle as quantum, single bundle as quantum, plural as quanta. So light is coming in form of quanta, and each quantum is having energy that is h nu. H is called as Planck's constant. C is called as speed of light, whereas here h, that is called as Planck's constant. I don't know what is connection between h and Planck's constant, but here consider that h as Planck's constant. Now you are aware nu, that is equal to, here also nu is there. So can I substitute value of nu over here? And answer is yes. So E is equal to h c by lambda. So this way we can correlate energy as well as wavelength. Based on this data, we can now classify radiations. We are aware of radiations, and I will give you here a general idea about radiation, and then we will come to know what is the meaning of spectra. So we will start here about the radiations. I will give here some chart. Now keep in mind, this chart I am arranging this way. This is increasing level of energy. Single axis graph is there, as well as I can say increasing level of frequency. Whereas if this direction I am drawing, I have to write here wavelength. So here we are getting shortest wavelength, here we are getting longest wavelength. Here we are getting greatest energy, here we are getting smallest energy. So like that radiations are there. So first I will write here, okay, this is cosmic radiations. So clear, it is cosmic radiations, but no much things are known about this cosmic radiation. Therefore I have placed here dotted line because some books are mentioning cosmic radiation, some books are not mentioning. But surely known radiation here, that is gamma. Don't get confused with nu and gamma. If at all it's there, then problem of Greek language. Okay, so this is radiation, that is gamma, which is very small wavelength is having, because it is wavelength is small, wavelength is big. So here wavelength is smaller, smallest wavelength is there in range of 0.1 angstrom. What is angstrom? In physics lecture fundamentals we will see that it is 10 raised to minus 10 meter. So even 0.1 angstrom is range of these gamma rays. Then X-rays. Actually a variety of groups are there of X-rays, but here right now I am mentioning only superficially, so they are called as X-rays. Then ultraviolet radiations are there, but we are calling them vacuum ultraviolet. Why vacuum ultraviolet? Because their existence is there in ultraviolet radiation, their existence in vacuum. The moment they enter in atmosphere, they get absorbed. Then ultraviolet, then violet. So we can keep in mind sequence this way: vacuum ultraviolet, ultraviolet and violet. Now violet onwards, so I am changing out color here of pen. Violet onwards, the radiations are different, that is Vibgyon. So violet, indigo, blue, green, yellow, orange, red. So this range, that is called as visible range of light. So here we are getting this all visible things here. Only this much spectra is visible. Now red onwards, we are getting here infrared. Then far infrared. Then microwave. Then radio waves. So these all radiations are again invisible. So these radiations are low energy, these radiations are high energy, and these radiations visible radiation. So this is called as spectra. Initially light scattered through prism, that is called as spectra, but now we realize that apart from this visible part, this is high energy invisible radiation, this part is low energy visible radiation. Now it is again and again, I want to tell that when we were discussing about J.J. Thomson's atomic model or Rutherford's atomic model, we were telling this way that it is not able to explain spectra. The thing is that every radiation, whatever the wavelength, is associated with energy. And particular element is emitting out particular wavelength only. That is called as characteristic wavelength. Say for example, sodium. On heating, one of the spectra of sodium is golden yellow. A few years ago, you are aware that street lamps, they were called as sodium vapor lamp. They are having golden yellow color. Now that is replaced by LED. But some 4 or 5 years ago, these lamps were made up of sodium vapor lamp, and maybe possible some of the cities might have continued that sodium vapor lamp use also. So that sodium vapor lamp that is having golden yellow color, that is characteristic wavelength of sodium. That's why if you observe from distance, say for example we are there in Mumbai, so when we are crossing out creek, at that time we were observing distant series of these lamps. All lamps are having same shade of golden yellow. It is not something is having pinkish, something is having reddish, like that. No, everywhere the shade is same. So that is called as characteristic spectra of that particular element. So why particular element emits only particular wavelength? Say for example, if potassium is there, potassium will emit lilac color. Calcium is there, it will emit apple green color. So why particular element emits particular color only? So this is not explained on basis of J.J. Thomson's atomic model as well as Rutherford's atomic model. And that's why we have to consider that the spectra is not explained on basis of this model. And to overcome this all, a new model was put forward that is called as Bohr's atomic model. Now henceforth, our study will go in much more detail. So let us consider now Bohr's model in next lecture.